based in Nuremberg. I'm the co-founder of NextHeat. And we develop a plug-and-play, hydrogen-based plug-and-play solution for the decarbonization of industrial furnaces. Our goal is to replace natural gas and other fossil fuels in high-temperature processes and decarbonize this sector. So, next slide. Yes, so a recent report from EY shows that nearly half of the companies in Germany already set net zero targets, net zero goals. And a problem of achieving this net zero is that many companies, especially when they have processes like manufacturing processes in high temperature that requires a high temperature, they have no real good alternative to natural gas. So in the sector, high temperature furnaces, you have examples like glass melting furnaces or ceramic production or steel or metal processing. So this process, they require high temperature. They are currently based on natural gas. And the alternatives for the future, if in a decarbonized society, are electric furnaces and hydrogen furnaces. And both have problems. So if you see the electric side, electric alternative, you need to replace existing furnaces, and that involves a lot of investment, of course. And electricity costs, at least in Germany, are 3 times more expensive than natural gas prices. So those are the big disadvantages of electric furnaces. And if we see the hydrogen side, you don't need to replace this existing infrastructure. So these furnaces, you can retrofit it. But still, there is no hydrogen grid right now. So if you want to do like hydrogen project, you need to produce hydrogen yourself. That means you need to buy an electrolyzer and have your own hydrogen production. That involves also capex costs, and it's also quite complex, the process. So you need to retrofit your furnace, take care of that as a client, as an industry. Then you need to take care of the hydrogen production. And you also need to take care of the electricity used in this process for producing hydrogen locally. And you also have some difficulties that hydrogen burners, for example, they have bad nitrogen oxides emissions, and also the electrolyzer, the electrolyzers are in the market, they are not optimized for that application. But you have a very important advantage in the hydrogen side. Those are the running costs, so the electricity costs. So you have the advantage of producing, for example, hydrogen when the electricity costs are low, because there is a lot of renewables in the grid. And in Germany also you are exempted of grid fees. So you have like a running cost advantage of nearly 70%. What is, of course, a big advantage for our clients. So our goal in NextHeat is trying to solve these problems here, these 3 problems, so that our clients can have advantage on the OPEX side. So a solution that is much cheaper with running costs. How we do that? So we solve the technological issue by supplying we develop hydrogen burners, and we have very low NOx emissions. So that's the hydrogen projects don't have any regulatory issues anymore. And it's important also to get hydrogen compatible with natural gas. You also need to reduce capex, as we saw. And we developed the first electrolyzer especially designed for process heat. And we can, with a simplification of the balance of plant, we reduce costs, and we also increase efficiency of the process. And our electrolyzers, they have integrated also an energy management tool, with which we can then offer our clients minimization or optimization of the electricity procurement. So that's about hydrogen project. So our business model as an equipment supplier of burners and electrolyzers, of course, we earn money selling those equipments. So and we are now the market entries is focused on entry-level solutions, so around 300 and 500 kilowatts. Of course, these capacities are very low compared to what our clients need. They need usually much more than that. But none of those clients here, they want to go for 100% hydrogen right now. They need first to prove that this new energy carrier can be used in their processes without any implication on the production processes, and also to check that the prices of the hydrogen production are also good, are low enough. And so entry-level solutions is exactly what they need, and it's perfect for those companies to get a experience with the use of hydrogen they process. And in a couple of years, when they have then they can take a decision of going for hydrogen, like we also with big scale and with very low risk. So they already know that, and by then we'll also be able to supply also bigger modules. Yes. Besides our equipments, we also earn money with service, so maintenance, operation, and most important also the power trading fee. So there we get then recurring revenues, and that's also very important. These are so. You see here in 29, our projections is to earn almost as much money with services, especially power trading, than the modules itself. Of course, the equipments, they are capital intensive. We have here, we reach break even at least locally here in 27, but with the upscaling, then a little further. And regarding the impact, so in the next 5 years, we can of course, achieve CO2 reduction, or our clients can achieve that by displacing fossil fuels. So we have also extraction. We already raised nearly 1 million euros in funding from Germany. And in July, we got a first client from the steel industry. So they process steel. You see the coils there in the back, and the furnace that they need hydrogen for as process gas, but also for a lot of heat also for their oven. So in the beginning, we are supplying then covering totally the demand of process gas in this thermal process, and later on the plan is then to replace also the thermal demand of those furnaces. So of course, there are other suppliers of electrolyzers in the market. Other electrolyzers, as already mentioned, they are usually more expensive, especially if they are based on other technologies like PEM electrolyzers. And electrolyzer is also not exactly what our clients need. I mean, our clients, they cannot start much with electrolyzer alone. They need a complete solution, so a plug-and-play solution. And we are the first who supplies that solution, that complete solution. So here's our team. We have in the development, we have Dr. Carlos Plana, and then Maximilian Falk in the operations, and me, myself, I am responsible for business development. Here's our roadmap. So in the last years, we were very focused on developing our modules, so our burners, and also the electrolyzer in a small scale. And now we are going to the commercial scale also with our first project, the first paying customer, and this project should be will be running in 1 year from now, and for that we are raising also 1.1 million euro. So that's our goal, fundraising 1.1 million euro, and with that we will be able of realizing our first demonstration project with our clients, as already told. We have already secured a little more than 400,000 euros with funding, so public funding, also a first investor, business angel, and also the first payment of the client. Yeah? So that's also what we intend to do with the money. So much of it is in the development, also part of it for the equipment itself, for the pilot facility. Perfect. That was it from my side. I will be happy to answer also questions.
Thank you so much, Fernando. Thank you for the pitch. And apologies that I dropped out of the call. We have some electricity problems here in the countryside. Apologies for that. Did all the advisors have time to introduce themselves? Yeah. Okay, great. Okay, so then we will move to the feedback. Gabor, would you like to start?
Yeah. Thank you very much. Thank you for the presentation. I actually have two questions. The first question is, can you walk me through how does your pipeline look like? So you mentioned this first customer, and I think it's a great milestone. And but I'm interested in also how many companies are you in contact with or have a discussion that can be your customers in your future, and what are their feedbacks and their expectations?
Perfect. Yes, so we our focus is on the equipment itself, not in developing projects. That way we can scale easier. But of course, with our knowledge in the combustion systems, we can also we have an advantage. I think that's also our USP, that we can much easier convince the client how to do that and what they need to check before switching to hydrogen and so on. So, but once we have a reference case, then we can replicate that. That's the idea, and then we need to do less project development and scale our production. Then our goal is then to have a production line for our electrolyzers, and then scaling up with that. We have, in Bavaria, where we are located. We have the best options also to the access to good clients. I mean, there are many industries, middle-sized industries in this region, and the interest is always big. We have a good client also for roof tiles. Actually, right now we hope it will be our second client, and they need a lot of energy. So per client we can have like a ticket size. That's also I put in the presentation. We have like a life cycle that KPI about life cycle. Revenues from one client is around 4 million. So we start with 500,000 tickets, but on the life cycle of that client, we can get the upscale and that get much higher tickets. That's the strategy, starting small, and once we are inside and our solution is proved, then we upscale.
Okay, great. And what do you expect for the lifetime of the electrolyzers?
The lifetime, I mean, we have 10 years is usual, so it's a guarantee, let's say, and then after that you need to how do you say that in English? So to
Recoat.
to do some retrofitting, is not retrofitting, something like that.
Recoating,
to extending the life and of the stacks. But besides that, the facility can run also 20 years.
Okay, thank you.
Thank you, Gabor. Next, let's hear from Bobby. Bobby's feedback.
Yes, it's wonderful technology, and but I have some question because I'm not a engineer based. The presentation make me a little bit confusing. But however, I just need to know, you are looking for funding, right? 1 million, €1, and this is to develop the first prototype.
Mm-hmm.
All right.
Yeah, it's already a commercial facility. So it's already a commercial scale facility. So it's a 300 kilowatt electrolyzer. Is already kind of big scale. It's not a small one, so it's a container facility. And,
okay.
Yeah.
All right. So what is your plan in terms of the scalability? Your focusing market is EU, or you plan to expand outside EU? What is your plan in the next 5 years?
For sure. So we see also, I don't know if you follow a little, but the economy in Germany is many industries have a little problem now, especially the automobile industry. So we are looking also outside. So we see a lot of movement in the hydrogen sector in the Nord countries, so Sweden and so on, because electricity is a little cheaper there, or cheaper than here, and other countries that have like a competitive advantage for hydrogen production. That's I think that it will start with this also in Germany, like it's moving a lot here, but you have some countries like Sweden also with the green steel production starting in Sweden, not in Germany, and so on. And of course, in other countries, we need to scale up also very fast, because otherwise, we see from batteries and others to stay like with the competition, we need to scale fast. And with internationalization, we're also talking with possible strategic investors, like I cannot mention here, but big players in the sector that also help us in the internationalization. So that's strategy.
Okay. And just one more question. How do you produce the hydrogen?
So the electrolyzer. So we don't do the stacks ourselves. So we buy the stacks and the other components also. So it's like we have some engineering of the facility, of course, and engineering, and it's an assembly line that we have then in the end. So it's the conversion of electricity and water into hydrogen. So the technology is alkaline electrolyzer, is called, and so it converts then the water using electricity to hydrogen. So that's the usual. That's the green hydrogen. It's called that. So and that's one of the only options to decarbonize these hard to abate sectors. It's called that. So especially high temperature process, for example, or green steel and chemistry industry.
Okay, all right. Thank you very much.
So the market now for alone in Germany is around 120 terawatt hours and 20 billion euros for our equipments until 2030.
Okay, thank you.
Thank you, Bobby. Okay, and let's hear the feedback from Wade.
Yeah, I think this was a great presentation. Thank you, Fernando. One of the most common feedback that we hear from our partners is that how do you protect your technology from others to get into this space? So when it comes to, we call it moat, what is the moat of your technology? I understand that alkaline electrolyzer has been around for a while. Burners have been around for a while. There are big companies that are doing it. I'm curious, like, what makes others not be able to get into this space? And what is your secret sauce in the core of technology you're building? If you could help explain that, that would be great.
Yep. So we have our own technology in the combustion. So of course there are burners, other burners, but in the hydrogen combustion there are some problems to be solved yet. And they have, for example, many in the market, they have bad NOx emissions, and we have very low NOx emissions. That's already an advantage we have. But I think also if you think about electrolyzers, as I already mentioned, electrolyzers are not a solution to our clients. They don't know what to do with it. So you need to pack that technology and adapt it to this application first, and need to pack to a complete solution. Like if you think about a glass production facility, they are not buying electrolyzer and doing the project development themselves. They need like a complete solution, like a plug-and-play solution that they put and they buy and build in their industry, and runs nearly the same as today natural gas, that you have a pipe coming. So that's our goal, to integrate those steps together, also with a good integration to the electricity market, and so that our clients can run without similar like what they do today. So other competitions in this sector, they don't have that. You need to buy one part here, you need to buy one part there, and they need to integrate everything. And we are the first of doing that, so we have the time to market advantage, and we have the advantage of we are good in convincing the clients, because we already know all that thematic of hydrogen combustion and hydrogen production. So they don't need to get different players and integrate all the solutions together. That's the biggest pain right now.
Okay. Thank you, Wade. And now we will hear from Jan. Maybe just one comment and question. We're running a little bit out of time.
Yeah, I'll keep it short. Thanks, Fernando, and thanks for the presentation. Perhaps also on the tech side, because I think that's interesting. If you look at your TRL, how far are you? So your let's say technology readiness level between 1 to 9. Where do you think you're currently at, and what do you need to prove to move to the next?
I mean, we're getting now with this first project direct to the commercial application. So we are in 1 year from now, we are TRL 9. Yeah. So, but still we are in the development. So we have just a small electrolyzer that we developed until now, and now we are upscaling. So that to a commercial facility. So yeah, but it's an engineering task. So to build an electrolyzer takes some development, and but we're already very, very far with the development. And as I told you, like in 1 year from now, we have then the commercial application. Yeah.
And perhaps one more short question. I mean, also the tech, we shortly discussed the uniqueness, but if you look at your, let's say, your patenting or IP strategy, can you share a little bit about it?
In the hydrogen production side, we still don't have a patent, but I mean, other suppliers of electrolyzers, they also don't have. Like it's a business of how to say, equipments or plant manufacturing. So like building a car. So, and also other competitors, they buy the parts from other suppliers, and they don't really have a patent on that. So yeah, we don't have a patent on that. So
fair. Thank you.
I think our biggest advantage is in the business model, not on the patent of the hydrogen side.
Thank you very much. Thank you, Fernando, for pitch, and everyone for the feedback. So now we will move to the second presenter, which is Ocean Harvesting Technology, presented by Michael Siedenmark. So hi, Michael.
Hello, everyone.
Yeah, great.
So can you hear me?
Yes, perfect.
I will share my screen. Let's see. Okay. So I hope everyone can see the presentation. My name is Mikael Sidenmark. I'm the founder and managing director for Ocean Harvesting Technologies, and we are working with wave power technology development. So why wave power? The magnitude of the transition to a clean energy system is so large that the wave and wind and solar power will not be enough. Much more renewable energy will be needed, and it's important with a mix of different types of renewable energy to help stabilize the grids. The global target for marine energy is to achieve an annual global market of 53 billion euros by 2050, and that 300 gigawatts of wave and tidal technology will be installed globally. What makes wave power interesting is also that it produces electricity more consistently and at different times than wind and solar. What this means is that it can help stabilize the grids and reduce the need for energy storage. And this in turn provides an added value in addition to the levelized cost of energy for wave power. Along with the transition to a clean energy system, it brings a lot of issues with grid balancing. So I think this is a very important aspect. Other values for wave farm installations is the low visibility from shore. You can extract about 3 times more energy per surface area compared to wind farm installations, and it offers great opportunities for co-location in the same areas, especially as floating wind power. So what is the problem with wave power, and how does the competition look? Of course, the harsh marine environment is one challenge, and also that the energy density of waves is very large, at the same time as the waves are rolling in with random size and random energy content, which makes it quite challenging to extract this energy efficiently. Previous wave power solutions have failed to reach the commercial stage because they have not been able to show affordable technology, and there has been several failures where these technologies have not worked. They have been destroyed in storm conditions, etc. But the industry has learned from a lot of lessons. A new generation of devices is being developed, which is much more efficient and have proven survivability. But there is still an issue of the affordability. And I would like to highlight resource efficiency as a key metric here, that there's a lot that can still be improved. Our solution is called Infinity Wave Energy Converter. It is based on 2 main parts, really. It's a highly efficient power takeoff, the machinery close to the seafloor, which uses a combination of ball screw actuators. It's a very efficient form machine element to transfer linear motion into rotary, and we can connect it directly to a generator without gearbox. And then the purpose of this component is to provide an instantly controllable force. This is combined with something we call a hydrostatic pre-tensioning system that doubles this force capacity at a very low cost. And what this does is to form a platform or a possibility to use advanced control algorithms. We are using model predicted control to tune the motion of the wave, the buoy, to match with the waves in every wave motion, which is key to achieve high annual energy production from these devices. So we have a solution that is highly efficient in producing high annual energy production with a quite small size. The other part of our unique selling point is the prime mover floating on the surface, which is a special design made like a honeycomb in a novel material called ultra high performance concrete. It is not our own material. It's developed by RISE Research Institutes of Sweden. It is applied in other areas as well, but they are adapting it for marine application. This is a concrete that is 5 times stronger than other types of concrete. And what it means to build a buoy with this type of material is that we can make it much lighter than it would be with traditional concrete. So we have a buoy of equal weight as a buoy with steel hull, but concrete is a 20 times less expensive material, and it can also be manufactured on close to the installation site, and it is much faster to manufacture compared to steel hull, which normally needs to be manufactured in a shipyard. So it is a much more cost-effective solution than steel hull, and it is also very important from a circularity and environmental perspective. It is also very essential to have a solution that is capable of surviving in this harsh environment, and our strategy is to hold the buoy submerged through large waves and to lock the system down in extreme conditions. Looking at what this leads to, I just explained what it is, what our selling point is, but what does it do? We are estimating a levelized cost of energy of around 100 euro per megawatt hour already at 100 megawatt installed capacity, and that this can come down below 35 euro per megawatt hour at gigawatt scale deployment. Another very important metric to look at, like as I mentioned already, is the material efficiency, which is about looking at what is the cost of the materials used per installed megawatt for this type of technology, which can be compared to any type of renewable technology. It's also important to look at the carbon dioxide footprint from the used materials. Assuming that producing these type of devices requires a large amount of material that needs to be considered. Looking at floating wind power, for example, there is 1,000 tons of steel that goes in every megawatt. So since we have been able to replace so much of the steel in this structure, and because wave energy is a more dense form of energy than wind, the comparison comes down to 6 times lower material cost and 6 times lower CO2 footprint compared to floating wind power. Compared to the leading wake developer, we are 3 times lower in the material cost and 4 times lower in the carbon footprint. So this is not the full picture. It's not LCOE, but I think it is very relevant to understand the future potential and how competitive a technology can be in the future rollout. The technology is now being taken forward to verify this material efficiency that I just talked about, the competitiveness, through 3 different projects. One project has been going on for about a year. It's about developing the buoy, efficient floating structure based on this ultra high performance concrete, and the honeycomb structure, which is IP from ocean harvesting. We have 2 use cases, one in wave and solar power. So the one in wave is about designing this type of structure for Carnegie Clean Energy's prime mover. You see the partners on the right. The other project, which is called Infinity, it's about developing new types of model predictive control, which is lifetime aware, and that this will reduce the levelized cost of energy by optimizing and balancing the annual energy production against the cost of the machine, the lifetime, the loads from this type of control. The other part of the project is to build the InfinityX power takeoff in scale 1 to 3, and to test this new control algorithm on the real-time control system. This has been a hurdle with model predictive control in the past, that it has been too slow to run on real-time control systems, but this is now being solved. And then the third thing is that the power takeoff will be tested on a generic test rig already built. So we are not we don't have to build a bespoke test rig, which has been a hurdle for the industry in the past. There is an existing test rig that will be used at VGA in Italy. So following these two projects is a sea trial where the power takeoff is refurbished and installed in a hull and put to test in the real sea conditions on the west coast of Sweden. The team and our closest partners look like this. I am the driving the innovation process and the concept development. And the entrepreneur behind ocean harvesting. We're working in close collaboration with Sigma Energy and Marine, where our main engineers are located. Andreas Berg has a very long experience from marine energy development, both in oil and gas and marine energy, and Johan and mechanical engineering. And Johannes Palm is expert in simulation and control. And these two expertises are very important to develop the system on one end and to evaluate the performance and loads on the other end. About this, all these three projects that I just mentioned are about developing and validating the Infinity technology, performance, and competitiveness through a 4-year period from 2025 to 2028. ReupCycle Plus is a project with a 3 million total budget, of which OHT's share is 200,000 euro with 60% grant support. Infinity is a project with 2.7 million euro budget. OHT share is 900,000 euro with 70% grant support. So most of our costs are covered with grants in these two projects for the coming 3-year period. So the sea trial project, that is the third project, it is not hasn't received grant support yet. We will apply for that when time is right. But we are expecting about half of this project that we can finance it with grant financing. So looking at the whole picture to finance also other activities and take us through these periods, we are looking at around 750,000 euro for the 3-year period where we go through the ReupCycle Plus and Infinity projects, and another 1.25 million euro for to go through the sea trial project in venture capital that we need to secure to go through this plan with the 3 projects. Yeah.
I'm sorry, I'm jumping in. Is it the last slide now? Or?
Yes, now it is. This is yeah. We can stay here if I have been running over time. So yeah, just the final word is that we are raising 300,000 euro now in the first round for next year, 2025. Thank you, and sorry for running over time.
Thank you very much, Michael. Thank you. Great presentation. All right, let's begin with Jan.
Yeah, thanks. Nice and interesting to hear. Indeed, a very interesting industry and specific technology you're deploying. First question is, given that, of course, there's a big tech component, how exposed are you to, let's say, supply chain failures, specifically with regard to component level, and what's your supply chain strategy?
Yeah, our strategy, and this comes down also to our IP strategy and development, is that we have moved from you know, when you're inventing and innovating, it's easy to develop components in-house, but realizing this, we have removed these components and are trying to use to get this to the market. We need to use components that are available and possible to manufacture with existing equipment. The ball screws, for example, is an example of this, where we have worked extensively with the ball screw supplier to identify how to create the right operating environment for the ball screw actuators, which is the key component to provide this type of force control needed to extract a lot of energy. We are our IP is about the system integration of standard components, where we have been quite good at picking the right type of components from other sectors to build the wave energy converter, which has this level of performance.
Thanks, Michael. And then a second follow-up question is, I think Core Power, one of the energy cohorts, they just got their funding Series B, I think 32 million. How and to what extent do you see that you can also catch up with those players who are perhaps more advanced currently than you are, or do you really distinct yourself from them?
Yeah, I think in terms of Core Power's journey, they are building. They have a different strategy than we have, and a different technology, which are kind of based on the same principles. But they want to develop a new Vestas, and I think in our case we are an engineering company, a technology project, if you like, and this plan with the 3 projects that we have just presented, our strategy is to prove the technology and the competitiveness we have with the material efficiency, prove our statements, and that we will attract industrial collaborations. So I think to be able to reach the end customer, the power companies and the oil and gas companies, we need to engage in collaboration with industrial companies, maybe find a host in an industrial OEM company that is capable of manufacturing large volumes of these devices. You should bear in mind that wave farms will not be single devices. It will be hundreds of these devices and very large values. So it's hard for us, a company like us, to grow into a company to deliver this to the end customers. We would like to take a shortcut and prove the technology to interest these OEM companies to take this technology.
Thank you.
And in terms of the difference in the technologies, I think I will not go into too much technical detail, but I can say that our technology, looking from a material perspective, material efficiency, we are using concrete instead of composites in the hull, and the power takeoff is less complicated and has about 1/3 of the weight in steel compared to Core Power solution. With if you look at the use of material per megawatt installed capacity.
Okay, thank you very much, Jan. And let's hear the feedback from Wade.
No immediate feedback. Congrats on the traction you get on the non-dilutive funding, government grants, and the science projects that you're doing. Thanks.
Okay, and now let's move to Bobby.
Yes, I just have a question. So because the character of the ocean in each region is different. So how is that kind of different from the ocean with a big movement or a slow movement? It can produce more electricity or less electricity, something?
Yeah, each site is unique in that they have different resources, and this can be a problem for wave energy devices, because it's not only the energy production that differs, it is also the lifetime of the machinery. So I think our strategy here is to design one power takeoff that fits all locations, but we need to adapt the system somehow, and that we can change the prime mover to adapt the loads and annual production to get the most out of the power takeoff design in terms of the lifetime. So the strategy is that the power takeoff is a fairly small unit, only 12 meters long and 2.2 meter in diameter when in contracted. It is small in relatively to many other of these wave converter devices. The reason why we try to stay within these dimensions is to enable the technology to be shipped in standard transportation, in standard containers. So it can be manufactured in the central location and then shipped anywhere in the world in an efficient manner. While the buoy, which is a bulky part, it's a 12-meter diameter, 4-meter high structure, which is impossible to ship in a good way. So that is also one reason why we developed this concrete concept that makes it possible to manufacture it on site and even with locally resourced materials.
Okay. And do you how you see about the maintenance of the system once you install in the ocean? It needs a maintenance.
Yeah, there will be maintenance needs. So the strategy is an installation procedure that allows us to with quick connectors to be able to remove the power takeoff. And there's a special way of installing the mooring in the buoy. So the strategy is to avoid having to do any diving operations. So of course, this is not something we have tested yet. We are in early stage and looking towards the first trials. But I think we have a well thought through strategy on how to transport and get this equipment to an installation site and how to install it without diving operation to make it feasible to install this large number of devices in arrays.
Okay. When I see your concrete base, I'm just wondering if sometimes there are a strong wind, it can move all your concrete away and we can lose them, right?
Yeah, it is a possibility that the line will break, and this is something. Of course, it will be designed not to, but if it happens, we need to have a strategy how to collect the buoy like this or how to secure it. So we don't have a full solution developed for this yet.
Okay. So it's very interesting because in Southeast Asia we have a lot of sea, but it's a slow sea. So if you plan to have to set up a pilot project in Southeast Asia, I come to help you. Just let me know.
Okay, thank you very much. Yeah.
Okay, thank you. Thank you, Bobby. Okay, let's hear a question from Gabor.
Thank you very much for the presentation. Congrats on the grant support that you got. I think it's an important milestone. My question is, how do you see the company in the future? So, I mean, you mentioned that you are an engineering company, but you see your company as stays an R&D company and selling the solution and the patent, or you're gonna be technology licensing, or you're gonna start manufacturing. So what is the business plan?
The business plan is licensing might be an option, but what we would like to and what we are going to work to achieve is to find a host for ocean harvesting in a larger structure, like an OEM company that we can continue to develop the technology and do engineering, like an R&D department, but with a lot more engineering support from this large organization, and that has the capability to bring it to the customer. So it could be someone like Vestas if that acquires ocean harvesting, for example.
Okay. Then you're looking for VC money, right?
Yeah. Right now,
So,
because it is a requirement for. We have so much of the total financing already covered in the grants, but it is never. There is always required a part to be in private equity.
Yeah, I understand it. But I wanted to see that when you are gonna, get revenue from it. So you're gonna expect revenues from it, from the project. With which part, and who is gonna be your customer?
Yeah, it is a special project in that sense. It's early stage. It makes it a little bit challenging case for VC in that sense, because the plan we have presented now is not going to bring the technology to the market. It will prove the technology, affordability, and operation in the real environment. But to get it to the market, it needs to replicate this project in full scale, and to certify the product. But this is not in our in Ocean Harvesting's costume as it is now. We need to find partners to take it through the full scale and commercialize the technology. So it is kind of a long plan to reach the market, but I think we have developed something very unique and competitive in the future landscape. So and that the exit opportunity for someone investing money now, I don't think it is so relevant to look at revenues in commercial operation. You would be looking at an exit scenario where this is acquired by this type of OEM or in some other joint venture form.
Okay, thank you so much, Gabor, and congratulations, Michael, for the pitch. Now we will move to the third. We have two more this evening. The next one is from Germany, and it's called ReupCycle, and it's presented by Alphonse. So, Alphonse,
Can you hear me?
Yes, perfectly.
Great. First of all, thank you, Mathilde. But I need to say that we are from Austria. Germany is the bigger brother of Austria, and we speak the same language, but with a different slang, I would say. So we are not from Germany. Yeah, and Tyrol is a very beautiful landscape with a lot of mountains. You can go skiing, and that's where we are from.
Okay, apologies. Yeah.
No problem.
Okay.
I just want to clarify. Okay. So my name is Alphonse. I'm one of the founders of Reps. And I'm happy to be here today to give you a short insight in our exciting journey and also in our invention. Because REP stands for, as you can read here, Road Energy Production System, and describes a mechanical energy converter that can transform lost energy from vehicles into clean electricity. In easy words, we integrate like 10 centimeter high plates into the ground at places where lost energy occurs. That's, for example, at exits on highways, on entrances, on ports, everywhere where velocity is reduced or where our slopes are acting. That could also be in front of curves. So our mission is clear. We want to provide the world an energy converter on roads that amortizes both economically and also energetically in a short period of time. And by doing so, we will not only transform these roads into a source of green energy, but also change the view of our currently energy production, energy recovery radically. So let's just go a small step back, because we are moving around in the field of energy harvesting. Energy harvesting describes the process of capturing lost energy from small vibrations, also small movements, into, for us humans, usable energy, of course, electricity. The field do have a huge potential if you just think about all the areas where these vibrations and small movements are acting. The problem here is that our well-known energy converters, for example, dynamo principles and piezoelectric effects, both fail in terms of efficiency and lifespan at the moment we put and take them into the field of energy harvesting. So that's the reason why we made 5 years of research to invent a mechanism that is not based on these principles. Our mechanism is based on the worldwide first permanent magnetic bearing. It means permanent magnetic bearing means that you do not have any mechanical friction component at the conversation step in the mechanism. It means that you're very efficient and you do have a long lifespan. We minimize the risk at a high level, and here's why. At the right picture, I try to zoom, hopefully you see it. You see one of our previous prototypes. There are movable components, they are called triggers, and under these triggers, there are hydraulic stamps. If something drives over our 10 centimeter into the ground integrated plates, we guide these impulses away from the road, away from the dangerous application area, to our energy module box. In this energy module box, there are our energy converters. So the big advantage here is now that we can maintain lanes without this, without interfacing the traffic, all the critical components. So the module, the hydraulic oil, also the electrical components. The only diable components could be the triggers. These are the movable components, and they are designed to be removable very quickly. So in summary, I can tell you that we made 5 years of research. We got the European patent at the core of the invention. That's very important to mention, and it's pending right now for the worldwide one. We already got a very good sign from USA that the document is already patented. It's just a process that needs time. We validated our test track in 8 months now, and we verified the energy yield from an external, from the University in Innsbruck, the mechatronics department. We also gained a lot of interest, and I will show you in the next slides also, for example, with Jens Meyer. He's the CEO of Port Hamburg and also the president of all ports worldwide. But I will tell you on a later slide. The potential just for these road power plants is very big. On the left side, you see the potential for all ports. The reason why I put it in here is because I wanted to explain you that we will start at ports. Ports are mostly private, and that's the big difference to public roads. And also we had luck with Jens Meyer, and he will be our first customer. But to give you a feeling about the energy output, you please need to look at our pitch deck, because there is described with different frequencies, different masses, and the different amount of installed plates, how much energy you could generate. But for example, if we would install 60-meter long plates, by sides 12 meters is the minimum we need to install to amortize. If we would install 60-meter long plates at the exits of the European highways, we could win back 6.3% of the CO2 emissions caused by traffic in Europe. And that's not just a small number. It means that we could win back 104 terawatt hour of clean electricity from roads yearly. And that's the same amount of energy as 10 middle-sized nuclear power plants. And by doing so, we save 46 million tons of CO2. And depending on the electricity price, you would gain yearly 10 to 31 billion euros. So to tell you about our business model and how we are going to make money, I tried to explain you on the example of the Port of Hamburg. It's important to mention that the business model, and that's the reason why I put free here, is changing with the country and the customer. We already made the learning curve. Then, for example, in UAE, they want to buy it. In Australia, they want a license. And in Germany, they would like to do a profit sharing. So if we would install 300 of these 12-meter systems, we could generate 12 million gigawatt hours, a revenue for each party of 1.3 million euros through selling electricity / using electricity, and an amortization of 2 years. Of course, that's the best case scenario, because ports, they're acting high masses with high frequency. And in Port of Hamburg, for example, they're acting 70,000 trucks daily driving into the port. So the reason why it's very interesting for the port is because we could save 8.4% of the CO2 emissions caused by the traffic in the Port of Hamburg. And as I told you, we met Jens Meyer. I wrote him a mail. We had a lot of luck. He flew to us to Tyrol to see the beautiful mountains. And he went to our test track, and he was very excited about it and told me he needs this one in his port. So he invited me to the World Ports Conference, where we connected with now over 30 CEOs of the ports. There are more than 200 CEOs. And we are now also in the process of getting the LOIs, of discussing. And it's all the same, that we need to make a potential analysis. We need to install a pilot project, and we need to negotiate about how we roll it out. So our mission or our timeline is clear. We need to install in 2025 November a market-ready product in the port of Hamburg. To do so, we need the time for this year to get the CE certification and the bus testing. The reason why we need it in private space, it's not necessary to get it. But if we want to roll it out in public area, we need these testings, especially in Europe. Then, of course, we need to do pilot projects in different countries, in different areas. We need to set up a manufacturing, and we need to roll it out and fly. So before I come to my last page, to my last slide, we are a team of 4 founders. I'm a physician. I'm a bit legasthenic, so it's very hard for me in English, but I try my best by the sides. We do have a university professor, 2 metal workers as founders. We do have a civil engineer. We are a team of engineers and scientists, to be honest. And we do have partners in USA, Australia, and in UAE. And all of us unites one thing, and that maybe you hear it, it's passion. And that it's the passion that we will not only change the view of our currently energy production, but also that we can make a very important contribution to our currently climate crisis, a very quick contribution. So here's what we need and what we offer. We need 2.5 million euros to get the technology ready marketness, to install it at the port of Hamburg, and to also get the counter financing here in Austria from the how is it called, FFG basis program. There you need 1 million, and then you get 2 million. We of course are connected with them. We need the investor to counter finance. I'll be very honest with you, and the reason why I'm here is because we closed 1 month ago an investor with 2.5 million, a well-known investor, and the well-known investor has of course has some problems, family issues, to get the money out of the company, and he needs to. I'm over the time, just 1 minute more, and he needs to wait until he get the bridge financing from his bank of 10 million to invest in us. I told him 3 days ago, we can't wait anymore. If it's okay, we need to fundraise. We need to find the right partners. We need to accelerate quickly. So what we offer, we do have a clear plan. We have a proven technology. We need the final development. We need to set up the pilot phase that it survives 6 months to roll it out. And we are looking for a partner who has the passion for our technology, and who also sees the potential to build a unicorn with us. So yes, I would be pretty happy if you look at our pitch deck at the Dropbox, and if you have any questions or need to contact me, I will send you my LinkedIn account in it and my email address. So thank you very much for listening.
Thank you so much, Alphonse. Great pitch. Thank you. Let's go to the first feedback. Let's start with Gabor.
Thank you very much for the presentation. It's a great solution. I'm just parallelly looking and reading your pitch deck in this Dropbox. Yeah, one question from us is can you help me with the unit economics of this solution? So if we want to balance the civil work and the product price, or the investment on the customer side, so can you walk me through it?
Could you just explain it again, please? Sorry, some English words are different for me. So what we do with the money, you were asking?
No, the unit economics of this solution. So if your customer buys your solution,
okay, yeah,
and you need civil work and the installation, etc., how how does it look like from the revenue stream part on their
Okay.
side and on your side?
Yes. For example, at the port in Hamburg, with the profit sharing model. So first of all, they try to help us to finance the test track that gives the proof. And then the idea is that they finance the 2 years of the amortization. So they finance the test tracks. And after they get the money back in the 2 years, then we share the profit. That's the model, how we gain a profit in the profit sharing model. For selling, for example, it's very easy. We sell our product, but we also offering maintenance. And for licensing,
what would be the price?
for example, at the port in Hamburg, we could sell it for 13.5 million euros.
Yeah.
And this means it amortizes for the customer in 5 years.
Okay, I see. And
Yes.
is it full amortization, or and you need maintenance, or you need maintenance during these years also?
The maintenance is not already calculated in, to be honest, because there are some parts we still need to figure out. And this is one part we are right now try to figure out to set up the business model, because one idea was to make your own business model for the maintenance. So it's not calculated in there, but the maintenance shouldn't be expensive, because all the components are away from the road. And we do have a permanent magnetic bearing. The only thing we could need to change are the triggers, and they are not that expensive.
Okay. Thank you very much.
You're welcome.
Okay, let's hear from Bobby. Bobby?
Well, yeah, I just
Yeah.
opened my microphone. Very interesting idea, because in Bangkok, we have a 10 million car for 10 million population of the car in a whole day, you see. So I think this can be the best, a very interesting solution for Bangkok. However, the point is Bangkok get flooded every year, inundation. And when you set up your stuff on the public road, and when it get inundated, it can be break, right? It can be malfunction.
I'm so sorry for my English. I just asked if I understood it right, because I'm good with numbers, but not with languages. You ask if it breaks.
I
Right?
asked, your innovation.
Yeah.
You put it in the public road, right?
Yes.
Right. And when you're in some city, they get inundation, flooding. When the road gets flooding. Okay.
If you change the road, you mean?
Okay.
I don't know the word flooding. I don't know the word
flooding, right? The high water, you mean?
Yeah, water.
Okay.
Yeah.
Yes, you mean what we do if it's floating?
Yeah.
In case of
Yes.
flooding. Yeah.
I will explain it to you. So first of all, the only components in the road are hydraulic stamps. They're made out of steel, and they're made out of hard plastic. So in every scenario, if something would happen, we electrify the hydraulic system, that we can control it from Austria, for example, to let the triggers down to be a normal road. It's important to mention that we, of course, need to fulfill the same regularities than a normal road. Otherwise, we are not allowed to install it in a public area. For example, now if water floats, we do have a civil engineer who developed like boxes where the water goes in and where it drives away from the plates into a system where it then is going to get into gas, if you know what I mean. If it's
Okay.
heating up, it's getting to gas.
Okay. When we are going to install your machine, we have to change the shape of the road, right? Because we have to put it underground, right?
Yes.
And
Yes.
that is but it's a public road. We need to ask for authorization from the government.
Yes, I know about that. You need to talk with the government, and in every country
Yeah.
it's different. But we only need 10 centimeters, and mostly it's the first layer of the road. So you are very quick to install it, and you only need to cut the asphalt, and you get the fixed miodrates into the road. We also do have experience with the ITC government in UAE. They gave us an LOI, and we learned that these countries are much quicker for implementing. And also with the government here in Austria and in Germany, it's just important that we fulfill the same regularities than normal roads. Then we are allowed to install it.
Okay. Right. And your business model, what is your business model? You sell your machine, or you profit sharing, or you kind of a subscription? I don't know. What is your
To be honest, on the first rollout we are planning at Port Hamburg, it's profit sharing. We need to prove the technology. We need to prove the business model. We need to prove all of this. And if we do have a reference project, I would like to sell also some systems, because it would be quick money to scale.
Okay, it's that about prototyping process, right?
The selling.
You mentioned it's in the prototyping phase, right? It's prototype. It's not a real commercial
Yes.
product, right?
Yes, that's why we need the money, because the technology works. We do have the energy yield. We need to get the CE certification, and we need the bus testing. It's like a testing in Germany where you get the stamp that you're allowed to install it in roads. So we need to get this product market readiness, with the goal to install a market readiness product in the Port of Hamburg at 25 November. In November 2025.
So, and the last question, why you want to raise for €2.5 million? This is to invest in what? In the more prototyping, or in technology? What is your plan to spend for spending this?
In several things. First of all, you can use the mechanism for many cases. You will see it also in my pitch deck. There are several interesting cases where we can use the same principle. We need the money for infrastructure, for machines, for the team of engineers. We already got over 200 applications in the last six days, where we didn't know that the investors' problems. So we invested into as you can see here, into the development of the market readiness product. So we need physicians, product developer, and mechatronic guys, that we get this thing market readiness, that we get the receipt of the manufacturing, and that we are ready to move with this into the next stage, into manufacturing. That's why we need the money. Also for more patents, we do also have a patent strategy, of course. But yes, that's the main point we need it for.
Okay, all right. Thank you very much.
You're welcome.
Thank you, Bobby. Okay, and now Wade. Wade? Or
no specific question.
No specific question.
Yeah.
Okay, then let's hear from Jan. Thank you.
Yeah, Alphonse, thanks. Interesting presentation, very innovative technology, so much appreciated. I have one question, and it's because, I mean, you're in the pilot phase, you're gathering a lot of data. So how robust is, let's say, the data which you are collecting from a data quality point of view?
The data about the energy yield?
Yes, exactly.
In comparison to what? Sorry, in comparison to?
So you're collecting data because of your system. You're proving that it works. You're proving that it's more efficient. how robust is your data collection? So how robust is the data which you have gathered over and with your
Yes.
projects?
So we do made 5 years of research. So we do have a lot of documents about the energy output, and we measured our modules himself with different masses acting, because it's also important to mention there are different impulses acting in different time frames. So it's hard to collect these impulses efficiently. So we measured it for the modules. We got over 95% efficiency, and we also measured it with the plates. And all of our research work about it is verified from the university in Innsbruck, from the mechatronics department. So we do have the stample, we do have the sign of the mechatronics department that were 3 doctors who made the measurements about it. So our quality about the energy yield, I would say, is very good, because mechatronics department, just by the way, in Austria, we were top 5, at least at my time when I started here, top 5 in the world of physics. So we do have in Taiwan very good engineers.
Thanks. Thank you.
Thank you, Jan. Okay, thank you, Alphonse.
You're welcome.
We will now move to the last presenter of the evening. It's Hashim Akbar from with the company ReupCycle App. So hi, Hashim. Whenever you're ready, you can share your screen.
Hello, everyone. Can you see my screen now?
Yes.
And the presentation is on?
Yes. Perfect. I'm starting the timer.
Perfect. Hello, everyone. I'm Hashim. I'm the co-founder at ReupCycle from Pakistan. Looking at the amazing things that everyone's been doing here, we're trying to solve a very basic problem with the purpose we want to leave the world a better place than we found it. So what the problem is all about the plastic pollution in the environment. So as we see, Pakistan is drowning in plastics, and not only Pakistan, it's all over the world. If you focus in on what's happening in Pakistan, there's an inefficient waste collection due to there's no proper waste management, a lack of formal recyclers, there is a non-existing recycling infrastructure, and there is hardly any awareness of the greenhouse gas emissions, which further leads to a disruptive ecosystem where microplastics are infiltrated. The river Indus in Pakistan is the second most plastic polluted river, which ends up gives plastic to the ocean. And then there's a adverse climate impact. Pakistan is the 8th most affected country because of climate change. And then there's a lot of economic value that is lost because of the poor collection, because a lot of the recycled PET and plastic industries that use recycled plastics as their raw materials are not able to get the sufficient supply to fulfill the capacity of their plants. 4.5 million tons of plastic is consumed annually in Pakistan, and 70% is mismanaged, which ends up in the environment. Why that's happening is because there are multiple informal players who keep the value chain inefficient and fragmented. So when we look at the value chain graph on the right side of the screen, it starts from the scavenger, which sells waste plastic per kg for 29 cents, $0.29, 29 cents in USD, and the customer buys it for 82 cents. So by the time it gets to the customer, it approximately increases by 3 times. The inefficiencies, the informal and unorganized, there's hardly any knowledge. There's a lot of middlemen, and the information is not openly available and shared with people. And there's no focus on increasing collection, on making it more efficient. Our solution is to disrupt waste management and improve collection through a decentralized collection platform. So we've got 3 sources to get plastic. One is the junk dealer. One are the institutions, which are schools, colleges, universities, restaurants, cafes, hotels. The third are people at houses who want to recycle because they don't have any source to recycle. They place an order on our app or send us or call us or send us a WhatsApp that we've got this much plastic that they either want to deliver to us or we go collect for them. And then we receive the order, we receive the plastic at our facility, and we pay the customer. Then we have our sorting operations inside where we sort it into different colors and the types of plastic. And then we wash it and we shred it into small pieces and supply it to industries that utilize it as a raw material. A lot of industries are utilizing it as a raw material, such as the recycled bottle manufacturers and the recycled food containers and the polyester fiber manufacturers who produce all kinds of different clothes using polyester fiber. The market for recyclables is huge in Pakistan. If you only look at the recyclables market in Pakistan, it's about $11 billion. We wanted to begin with plastic because it's a $4 billion industry, which is about 35% of the total recycling industry in Pakistan. And there's a growing supply of plastic. Plastic is the biggest problem in environment at the moment, and there's a growing demand for recycled plastic, not only in Pakistan, but globally, because a lot of these people want to utilize it as a raw material, but there's demand is very high, but supply is very low. And then the extended producer responsibility, where in Pakistan it's not currently fully in play, but if we look at it from a global standpoint, there are multinationals operating in Pakistan who do have the extended producer responsibility. And then the cost competitiveness is also very good because recycled plastic is 50% the price of virgin plastic currently in Pakistan. We've collected over 10 million plastic bottles in the last 12 months. And now we were at a choking point. We started at a facility, we choked in January, moved to a bigger facility, and now we've choked that again. We're collecting close to 60 tons of plastic every month, and we see this number can grow by 10, 20, even 30x with bigger facilities. Our GMV has stabilized and we've reached a choke point where we're doing an MRR of $35,000. Our CM1, which is contribution margin one, our buying and selling price, that's at 31%, so that's $11,000. And the average cost post-processing, which we call the contribution margin two, we have 19% revenue left over. And at CM3, which is after delivery and warehousing, we still have 10% left over at the current scale that we are. When we have economies of scale, we grow bigger. This margin will keep on increasing. We're looking to raise $1.5 million to build and scale to have sustainable growth. About $500,000 goes into working capital. The capex for machine processing, because there's certain processing that we need to do, is about 250,000. The infrastructure development is also 150,000. Then we need to hire a team which helps us grow and scale this business, which will be around 250. And we further need to build on our tech capability. And in the next 3 years, we aim to grow by 30x, where we're going to be collecting 14,000 tons of plastic per year. Our vision to grow and expand. So by 2027, we see that our EBITDA is going to be $2.6 million. We have designed that we're going to make it a hub and spoke model where you have different spokes to collect, and we have a central hub where we transform all this plastic into a raw material and not only serve the local market in Pakistan, because once we do have the big quantity, we can start exporting it too. And then we also going to start developing a marketplace because we wanted to first understand the recycling space of all recyclables, and we decided we want to take this, scale it further through a marketplace, because we see that there are a lot of people doing selling a lot of recyclables, but there isn't a central place where someone can go and buy recyclables. So we want to evolve into a B2B marketplace for recyclables. And then the sustainable development goal that we're addressing is responsible consumption production, gender equality, decent work and economic growth, industry innovation infrastructure, life below water, life on land, and climate action. The 3 year socio-economic impact that we're looking at is there's going to be 24 million kgs that we will be diverting from the landfills. We're going to be reducing 30,000 tons of carbon dioxide emissions, and we're going to be increasing female labor participation in Pakistan, because in Pakistan there's a big how do I say we don't have a lot of women in employment. So we want to bring those also into employment, because we're focusing on a triple bottom line, which is people, planet, and profit. Our vision is to become a one-stop shop for industries to source all their recycled raw material. And the people behind the vision is myself, Hashim Akbar. I've worked across Fortune 500 companies, big tobacco, now trying to save the world. Then I have Inam, who's worked at companies like Nestle and Friesland. We were both at Bazaar, which is the largest and most well-funded startup in Pakistan at the moment. And our CTO co-founder Omer, he was a gold medalist in university, and he's worked at different startups and is currently working with Riva, which is a Saudi-based POS startup. So we're trying to save the world by reducing the amount of plastic and building a better circular economy. And we would love for you to invest.
Perfect. Perfect and right on time.
Yeah.
Very good. Okay, very nice presentation. Okay, who would like to start? Maybe Wade?
Yeah, first of all, great job. I don't know if my internet is stable or not, but great job with timing. I thought that was one of the things that stood out. Secondarily, I mean, congratulations on the recent traction that you're making with, your monthly recurring revenue and the tons of plastic collected. I think that's pretty telling on what you're doing. One thing that I did want to put out there is, as you noticed from, I'm sure that Matilda and the team have already explained who your target audience is in this particular event today. I don't know if anybody is really privy to what's happening in the Pakistan market. You emphasized a lot on it. I'm not saying it's bad, but I don't think it was curated to your audience. I don't know if anybody, including myself, is aware of, the regulatory environment in that region, the policy, the competitive landscape. I don't know if it was fully touched on what the companies are doing. We, like I said, at Plug and Play have invested in companies that are in the plastic recycling space, and we partner with the Alliance to End Plastic Waste, which is a global alliance of some of the largest companies out. We run their innovation hubs globally in 12 different hubs. I think, like I said, maybe just a quick point here is like, make sure that when you're presenting to an audience, know your audience a little bit better and then tailor that to their needs and interests and knowledge. So I think, you kind of like, we're torn between Pakistan market, global market. That in and of itself is a lot to unpack. And I think with the limited time that we have, usually in the introductory presentations, it's hard to tackle it unless you have put in a lot of time to curate that. And then, of course, there are a lot of other questions around like scalability of it. How do you collect plastic away? Because you did talk about the junk dealer collects and the institution sorts and things like that. But again, I have zero knowledge of what's going on in Pakistan market. I may know a little bit better in Europe and US, but that's something to just point out. Otherwise, good job. Keep up the good work.
Perfect. Thank you so much, Wade. I think that's where it comes in, that if you are interested, then we can potentially give you more details, because yes, I think the regulatory environment and everything is very much relevant to what is happening in Pakistan. But yes, I think it's a global problem that we wanted to solve, and more so, I think our model is curated towards developing countries. But I think point well taken. We should try to give a more holistic view picture of Pakistan.
Okay, thank you, Wade. Let's hear from Jan. Jan, cannot hear you.
Sorry. I like the presentation, so thanks for that. I think the comments just made were on point, so I also agree with that. If I look at the question, I actually want to touch upon this slide, because if you look at your model, so you're trying to solve these inefficiencies, but if you look at your specific model and your value chain, what's there, let's say, your weakest link, and how do you mitigate it? So how do you make sure, for example, the collectors are properly incentivized? So what's then, let's say, the weakest link, and how do you address it?
So I think the weakest link is majorly the aggregators and the middlemen. So the collectors, we're trying to digitize them. So we finish off the aggregators, middlemen in between. So they do get access to the end market. They don't have to go through people and share their profits in the end.
Clear. And Hashim, within, let's say, then in this case, the Pakistani market, your direct competitors, can you tell a little bit about that and how you differentiate from them?
So our direct competitors are mostly in the informal sector, and for them, there's a very how would say that there's a very up and down in terms of supply and demand. So if they get 10 tons a month versus 20 tons a month, they're okay, because they don't have consistent operational SOPs developed, which we have developed, because there's a very specific way of what we're doing. We're collecting through multiple sources. We pay on time to make sure that people improve collection and are incentivized, whereas they're just doing it in a way where they're not very focused toward a growth mindset, whereas we want to expand it throughout and then potentially go global with everything.
Thanks for that, Hashim.
Thank you. Okay, and now Bobby's questions or feedback.
Yes, I see a model. I see this this kind of model we can find in every developing country where the government doesn't work well. We have to deal with the waste by our own. So thank you to making this, because not many people who want to make a dirty job as you are doing. And but however, I'm just curious to know who you are selling your waste to as a material. You have who is your customer, and right.
I think starting with that, do you have more questions, or should I just answer this first?
Oh, just one by one. I want to know who is your customer who buy the material from you.
Yes, so we have two major customers industries. One are the textile industry, who manufacture polyester fiber from recycled PET, and then there's recycled bottle manufacturers who supply these bottles to Coca-Cola and PepsiCo in Pakistan.
So they reuse your material to make a new bottle?
Yes.
Okay. Is it not forbidden in by the law?
No, so the washing lines that are present are all FDA approved washing lines. So it's completely hygienic. They completely remove all the contaminants and impurities, and then they go into and they're food grade quality when they're recycled.
Okay. How many years you operate already?
We'll only be live now. It's about 12 months that we've had operations. We started November last year.
12 months. And okay, so you don't have your income traction to show how it's work, how your business goes well.
Yes, so we've started making money since December last year, and now we're
Okay.
consistently making $35,000 worth GMV, and
Okay.
and we're still left with 10%. But if you look at revenue take rate, that is 31%, which further would grow when we have more economies of scale.
Okay. You said when you supply your material to your customer, like and here they make a bottle for Coca-Cola. There are any chance they invest in your company?
So we've been having discussions with them, but I think for us to become bigger is when they become more interested in investing versus at the current stage we're at. So we're currently doing 60 tons. When we start doing about 500 to 600 tons, that is when people do get interested in what we're doing and we are investable. So currently we need belief for us to help us grow to that level where everyone wants to jump onto the bandwagon.
Okay, the 1.4 million US, you want to invest in your infrastructure, in your team, right? To make it bigger, right?
Yes.
Okay. Actually, this is my just a small comment. You should find a more credible customer to show that you are working with them, because we don't see your customer. We don't know how to balance your supply and demand of your customer. You see.
Yeah.
So the project without when we invest in this kind of project, what will be the return, and you have to show this kind of this part to get more interested in your project.
Sure.
Okay. I have no questions.
Thank you. Okay, and Gabor will close the discussion.
Okay, thank you for the presentation. I think it's congratulations on the traction. I think it's great that you have started the operation this year and already have paying customers reach this kind of revenue monthly. That I think that's great, and the collected amount of bottles and plastics. And my question is that what kind of plastics that you are particularly collecting? So it's type which plastic?
So currently we're focusing on PET,
Okay.
but now we're also going to start PE, and then LDP is what we're getting. So we're developing the different plastics. So the major recyclables is PET, LDP, HDP, and PE. So we've already this is all PET at the moment.
Yes, okay. And my other question is, I saw on your pitch deck that you are also not sorting, cutting, but washing also the plastics. How effectively you use water? Is it used in a precise machinery that you use, or how does it look like?
So we recycle a lot of the water that we use. So we have tanks where we put in the dirty water, it gets cleaned, purified, and then we reuse it to wash it. So we make sure that the water that we use is not wasted, and we do continue using it till about 10 to 15 tons.
Okay. I think I got all of my questions. So thank you very much, and keep going with this mission. I also really support, and I'm glad that you are helping women in finding workplaces. So I think it's a great mission.
Perfect. Thank you so much.
Thank you. Thank you so much, Hashim, and everyone for joining the event. Thank you for your time, and thank you that you stayed a little bit over the schedule. I really appreciate that.